I'm increasing the font size a bit so that it gives you more clarity. Custom font and making it 14 size, so better visibility. All right, first thing is to install Docker on Oracle Linux 8, you need to erase one packet, and the package name is runc. By default it is installed. You need to erase it. DNF erase runc and space -y. You remove this package. Once the package is removed, you need to configure the repository for Docker CE, that is Docker Container Engine. And this will install other packages also, like Cockpit, Container, Containers Common, Podman. These packages will be removed. So after erasing these packages, you need to configure the repository, and the repository is simple command dnf config manager add repo, and the repository is available here, download.docker.com linux centos dockerce.repo. Remember, this command is spread into two lines. If you want to put this command in one line, then you have to remove this slash. For example, see, I just use this up arrow key and the slash is no more visible, because this slash is used in Linux when you want to spread your command in two lines. If this is a one line, the command is quite simple, and command is this dnf config manager as add repository and the repository URL. What this command has done is this has created one file under etc yum.repos.d with the name docker repo. This is the repository file which is created by this command. After this is done, you are good to start, good to create that install Docker CE. So the command is dnf install docker-ce and then -y. This will install Docker CE plus all dependent packages. Remember that you have to remove runc first, then configure the repository, and after you configure the repository, it will install Docker CE and the dependent packages. You see, all dependent packages are being installed, and many packages are coming from Docker CE repository. Some of them are coming from OL8 app stream. So depending on that, it will resolve the dependencies. That's the beauty of dnf command or yum command, that it will take care of the repository itself, and it will resolve all the dependencies on its own. So it will install all the packages dependent, the dependency packages which are required for this software to run. After this is run, after this package is installed, after the software is installed, you need to run the command to run the daemon. You remember in architecture I talked about that Docker run in the background as a daemon process. So daemon process is a process which does not require a terminal, which run in the non-terminating loop in the background. That is requirement. So that Docker daemon needs to run, and the command for that is systemctl start Docker. And to ensure that it starts after you reboot your system, the command will be systemctl enable Docker. And if you want to do both these commands in one single command, that you can do with systemctl enable --now Docker. So I'm going to use this Docker systemctl enable --now Docker, which will do two jobs. One, it will start Docker. So systemctl enable, this will enable my Docker daemon to start every time I reboot my system. To start it right now, I can use --now and then Docker. So this will create a symbolic link to ensure that it start Docker after you reboot, and it has started Docker now also. That we can verify with Docker status. systemctl status. So this is the daemon process which is running now and is ready to take our commands. Q is the shortcut to come out of this. So now I can verify docker info. That will give me information about my Docker. And you can see here in Docker info, context is default. Docker info, context default, debug mode false, plugins, these are the plugins installed. Docker build, Docker compose, then Docker scan. Then containers right now, 0 containers, 0 running, 0 pause, 0 stopped, and 0 images. Server version 23.0.1. Storage driver is overlay 2. Backing file system XFS. Interesting point is observe this carefully because we are going to change it for our Kubernetes requirement on day 3. Right now I'm not going to make any change to this, but on day 3 we will be changing it to systemd. That is control group driver should be systemd for Kubernetes container. We are going to change it. So that's the information about Docker. If you look at IP space A, you will see one interface also created, that is bridge interface, Docker 0. This interface is created so that containers which you create, they can talk to each other on this IP address, this CIDR block 172.17.0.1. Means whenever you will launch a container, the container will get the IP address from this CIDR block 172.17.0.0 interface. So this is our existing NAT interface. This is our host only adapter, and this Docker 0 is created by this Docker daemon process. Now let's run a simple hello world example. So for that I need to pull an image from Docker Hub. Remember in the architecture I told you that we need to pull the image. So Docker pull hello world. Hello world is a simple image which is used to verify whether the Docker is successfully installed and it is working and able to download images from Docker Hub or not. So Docker pull hello world. However, if I run the command Docker run, it can do both the jobs. First, it will try to find out the image locally, and if the image is not found locally, it will pull the image. So I could have directly used the command run, but I'm not using, just for the demo purpose. So I'm using Docker pull. So I'm explicitly downloading the hello world image from Docker Hub. So image is downloaded. Now if I see Docker info, you will see at least one image is available. Here is the images, one image you can see here. To check the containers running, you can use the docker ps command. There is no container right now. -a running or stopped, both type of container, whether running or stopped, you can use docker ps command. So let's run this container docker run hello world. So now the container is running and you can see that hello from Docker. This message shows that your installation appears to working to be correctly. Now interestingly, if you run docker ps command, you don't see anything because this container was a very quick container which was created, which run demonstrated something and came out of it, exited. This container was not in non-terminating mode. If you see the stopped container list also, that is with the -a, you will see the container available. So this is a container ID. This is run from this image. This was the command 30 seconds ago, and this was the name given. This kind of names are a randomly appearing name. Like if you run it again with the same container, docker run, and you can use the container ID. You can run the same container with this command, and it will. Oh, sorry, docker run, and the container name. Container name was different. So I missed that. Container name was here. What is displayed? This one. So I can try using this also. So this is searching for image. I never wanted that. I want the container ID to run. So if I run docker run hello world, it will run again. But interesting fact here would be if I run the command docker ps-a, you will see two containers created. So every time you create a container with this command, you are getting a different name. Let's look for something interesting. Let's look for a container with a simple utility container where you can execute many commands. And that container is very good container is busybox. So docker pull busybox. This will pull the busybox container image from Docker Hub, and then you can run the busybox. That is a very small, very small image to run basic Linux-based applications. The bare minimum. Look at the size that you will get from here. Docker images. You see the busybox image size is 4.8 MB. So it is a very small size, 4 MB size image, and this was your hello world image. This is the size of the image, very small size images. Both two images are available now, and you can run the container based on busybox also. You can pull other images. What if you want to search something, whether I have a image available or not on Docker Hub for a given application? As an example, let's search MySQL. It will search the entire Docker Hub and will show you the images available. Like MySQL is image is available, and this is official image. Don't get confused. This official does not mean that it is a MySQL Oracle MySQL image, because MySQL is owned by Oracle company. This image is not from Oracle. This image is from Docker community or Docker server. MariaDB, these are all Docker images. If you are looking for MySQL images, you probably look for account MySQL/MySQL. In that case, the account will be MySQL, like Google MySQL. You can see similarly you'll find MySQL/MySQL also. Let me pull that image and let me check that and download that image which is hosted by MySQL. So I'll type MySQL and I'll simply search. I know I'm confident docker pull MySQL Server, and which version I want, 8.0. This is called tag name. If you type latest, it will download the latest. If you want specific, you can type the version name. So tag name does not mean always that it is version, but it signify the version. It represent version number of the image. So if I type 5.7, it will download 5.7 version of MySQL. So I'm downloading MySQL 8, MySQL Server 8 version from Docker Hub, and is pulling that, and you can see that multiple layers are being pulled to build that image. So this is how you manage the images, how you work with the images, and you can run the containers also. Let's see the session on installation now. So session 2, Docker installation, installing Docker on Linux, understanding installation of Docker on Windows, and some Docker commands. Installing Docker. The Docker installation packages are available in official Linux repository if you are using Oracle Linux 7 and earlier version, or CentOS 7 or RHEL 7. I have not updated this slide deliberately because this statement is not correct now. If you have seen the demonstration, if you watch the demo carefully, this statement is false if I say that Oracle Linux 8. And why do I say that? If you're watching, you know that I configured a dedicated repository, Docker CE repository from Docker website. So I configured the repository and then I installed. So it was not available in official repository. Why it is not available? Why it is removed from the official repository? The answer was available when when I run the command dnf erase run c, because the containers can be managed by docker command and podman command, and there are many other container management systems which can be used. All right, so by default Oracle Linux 8 and RHEL 8 and Rocky Linux, which is Rocky Linux now, earlier it was CentOS. These Rocky Linux, earlier CentOS, now Rocky Linux, RHEL and Oracle Linux 8 version, 9 version, by default they use Podman. Podman is also container management system just like Docker, but the difference between the two is that Podman does not run as a daemon process. It is a simple command and support all those features whatever Docker supports, but with the advantage that it does not require a daemon process to be running. So if you're using Oracle Linux 7 and earlier version, the command was yum install Docker engine and it was available directly in the repository. After installation, you need to start the Docker daemon, and that is systemctl start Docker. Verify that it is running with systemctl status Docker. We have Docker desktop for Windows also, for Mac also, and you can use that for next today and tomorrow, but on day 3 you will be needing Linux machine for our container training, Kubernetes training. Docker desktop for Windows is community version of Docker for Windows. System requirement is you need to have Hyper-V enabled. Hyper-V backend and Windows containers. Windows 10 64-bit Pro Enterprise or Education build number 17134 onward. Hyper-V and container Windows feature must be enabled. Then you can also have WSL2 backend, Windows 10 64-bit Home Pro Enterprise or Education version number 1903, build number 18362 or higher. Enable WSL2 feature on Windows. Common hardware requirement is 64-bit processor with second level address translation SLAT and 4 GB of RAM. BIOS level hardware virtualization must be enabled in BIOS setting. If you are using Intel based machine, you can go to the CMOS setup or BIOS setup by pressing Del key or F1 or F2. That depends on the motherboard and depend on the make and model of the laptop or desktop. So in that CMOS setup or BIOS setup, you need to enable this Intel VT or Intel virtualization. Remember, note that I struggled 3-4 days in my initial days when virtualization was just new, and these laptops and desktop machines started supporting virtualization. So we had to struggle because no help was available. Internet not was not that friendly at that time. Not much of the information was available on the internet. So we have to struggle to find out this Intel VT enable. If you are using Windows, then these are your steps. If you have not already downloaded the installer, you need to download it from hub.docker.com, Docker Hub. Then run the installer. When prompted, ensure that you select this enable Hyper-V Windows feature or install required Windows component for WSL2 option 2 is selected on the configuration page. Follow the instruction. When installation is successful, click on close. Then if you are running this Docker for desktop as administrator, then fine. Otherwise, you have to add. If your admin account is different from your user account, you must add the user to the Docker user group. Run computer management as administrator and navigate to local users and groups, and then go to the groups and Docker users. Right click on the user and then add that user to the group, that is Docker users group, and then log out and log back in and then start working. However, our training and entire production system never use this desktop version. Docker for desktop is never used. What you use in Linux machine, because in production we use only Linux. So when you are working on Linux or Mac, then it's better to be familiar with the command line interface, not the desktop. Using Docker consists of passing it a chain of options and subcommands followed by arguments. So the command, general syntax of the command is Docker followed by option or options and then command and the arguments. To view all available commands, you can type Docker, simple Docker, nothing else. It'll show you all the options. So these are options like -c, -d, -h, -l, and then after that you type the command. Commands are available here like build command, info command, all right, the command which I demonstrated. System information, I demonstrated that, docker info. And you recollect that when I use docker info, I got similar output. Containers, running container, paused container, stopped container, images. Server version was 23. When I created this lab assignment, I mean this presentation, it was 19 version at that time. Storage driver, and I also emphasize that take note of this line, C group driver. Control group FS, C group FS, that is control group file system. We are going to change it in our Kubernetes training. Working with Docker containers. Docker containers are run from Docker images. These images are hosted on your local machine. I mean, if you have built yourself, or Docker Hub, or any other registry. By default, it will pull the images from Docker Hub. Like I used Docker pull hello world. Anybody can build and host their images on Docker Hub. And you will learn that in this training to build and push the images to Docker Hub. To check whether you can access and download images from Docker Hub, you run the command docker run hello world, which I have demonstrated. In my case, if you notice, I use two commands. First, I use docker pull, and then I use docker run. Now, I also informed at that time itself that you can directly use docker run command. It will search the image locally, and if the image is not found locally, it will go and search the image at Docker Hub, and it will download the image and run the container from that image. So that's what you will get, this kind of output. Like when you directly try docker run command, it will check this, enable to find image locally. Therefore, it will pull the image from Docker Hub, and then it will run the container and display the output when the container is run. Container can be interactive. An example, let's run a container using latest image of MySQL Server. The combination of -i, which stands for interactive, and T, that stands for terminal, switches gives interactive shell access into the container. So that's what I demonstrated. I have pulled this image, by the way, MySQL Server. I pulled that image, and from this image I want to run the container. So docker run, and name of my container will be MySQL1, and -d means detached mode. Generally people call it as daemon also, but right word is detached. Detached and attached. What is the meaning? If you don't use this -d, it will take this terminal and will not leave the terminal, which means you will not get shell prompt back as long as the container is running. You need to press Ctrl C or terminate the container, then it will give the terminal back to you. So if you want to run this container also and want to get back the shell prompt also, then you have to run it in detached mode, -d. So docker run, name MySQL1, detached mode, MySQL account name, MySQL-server image name, 8.0 is the tag name. So again, notice that I am running directly without pulling the image, so it will do the same process here, enable to find the image locally, and then it will pull the image from Docker Hub, and then it will run the container based on this image. To initialization for the container will begin, and the container will appear in the list of running containers when you type docker ps command, like docker ps. Because MySQL is a non-terminating container, it runs as a daemon process. So therefore, you will get this ps command output. Docker ps command will give you the name of the container which is running, for how long it has been running, with the name and image, and the command which started, created, status, and ports which is open. I'll give all these details about the container. The -d option, as I explained in the previous slide, that was used in the docker run command above to mix the container in the background or detached mode. Use this command to monitor the output from the container, that is hyphen logs command, sorry, docker logs and the container name. That will help you in understanding the logs of the container, what is going on inside the container. In fact, when the container run, these logs are used to get the temporary user ID and password as well. So when you get the log MySQL, you will see the temporary password, generated root password, and you'll see this password. This password is required to log in when you connect for the MySQL server for the first time. And that can be explicitly grabbed using this Linux command, docker logs container name, and this symbol is very important, 2 greater than symbol %1. This 2 greater than symbol means error redirected. 0 for input, 1 for output, 2 for error. These are file descriptors. We call them as file descriptors. And these are used to redirect input or output or error. So 2 followed by greater than symbol means I'm redirecting the errors. Where? %1. 1 is for output redirection. % is for appending. So I'm redirecting errors and output both. Where? To the terminal only, because I'm not giving any file name. I'm attaching this to as a pipe, and the pipe symbol, after the pipe I'm using grab command, generated root password. So this gives me the generated root password in one line. It will grab that password and it will help me to get the password of my MySQL server. Now we need to connect. We got the root password, we got the server container running. How do we connect to MySQL running inside the container? We can use -it command, interactive terminal, docker execute -it to start MySQL client inside the Docker container, like this: docker execute -it container name, command which you want to run inside the container, and the command is MySQL username root and the password. So after that you will type the password which you have grabbed in the previous slide. So enter the password. So docker execute -it MySQL1 MySQL username and password, and then you type the password and you are connected. Now what you do as a first step inside your MySQL server, obviously you would want to change the password, and that's what you are doing: alter username identified by new password. Container shell access. To get the shell access inside the container, like MySQL server container what we have just now launched, you can use docker execute -it followed by bash or the shell name, like this: docker execute -it interactive terminal container name and the shell we want to execute inside this. So you'll get a shell prompt. This shell prompt is inside the container, inside MySQL container. So you are working inside MySQL container now. So ls command and whatever command you do, whatever commands are available, those commands you are running inside the Linux, this MySQL container. To stop the MySQL container, you can use docker stop. When you stop the daemon process, I'm talking about systemctl stop my docker, the main process, that is a docker daemon, when it is stopped, the container will also stop automatically. If you want to start the container manually, which you have stopped, you can use docker start. To stop and start, you can use restart, docker restart. So docker restart MySQL1, it will stop the container and start it again. To delete the container, you need to first stop it. You cannot delete the container which is running. So you need to stop the containers and then you run the command docker rm. Docker rm, that is remove MySQL1. To view all the containers, you can use -a, that is stopped and running. All containers will be displayed using docker ps-a command. To view the latest containers which you have created, you can use -l switch, that is latest containers that can be grabbed using -l, docker ps-l. Stopping a running or active container is as simple as typing the container ID, docker stop container ID. And this can be used to clean up. Like first list all the containers, stop all the running containers. This will stop all of them. Because what you are doing here, docker stop $sign means whatever the output of the command is inside the parentheses, like there are 10 containers, it will pass one by one to this command. So like this container number 1, so docker stop container 1, docker stop container 2, docker stop container 3, docker stop container 4, all containers. And what this command is returning, it is returning docker ps-a-q. So you can directly try this command separately to list only the container IDs. -q means quick. Quick means we will not display multiple columns, it will display only the container IDs. That's the reason you are passing the container ID to the stop command. So docker stop and all the container IDs you are passing as an array. It will stop all of them. And it will remove all of them now. Remove all the container IDs. Docker images, it will display all the images. Similarly, to remove the images, you use RMI command. RMI, remove images. So docker RMI -force and the same command docker images means list all the images, -a-q means only the image IDs I'm interested into. So these three commands, docker stop all the container IDs, docker remove all the container IDs, and docker RMI all the image IDs. Three commands can be used to clean up the entire work you have done. Managing a volumes can be easy, like the storage, external storage I was talking about. Unlike bind mount, you can create and manage volumes outside the scope of any container with command docker volume create my volume. So it will create the volume. To list the volume, you can use docker volume ls. To inspect a volume, you can use docker volume inspect and volume name. So this will display the complete details about the volume. And to remove a volume, you can use docker volume remove. That's all for this session. Recording of the lecture is available and you can watch the recording, and next 15 minutes is for doubt clearing. That's all for this session. Thank you very much.